So our next chapter here is then going to be chapter 4. And so this chapter is about work and energy. I know you've used the word energy for a long, long time. Very few people really understand energy. So what my job here is to come back and try to teach you about what energy is. So let me give you an overview of where I want to go with this. So the first thing that we got to do here is we got to talk about work. Work is the key to understanding energy. And I would say that this expresses the most common sense way to talk about energy. Very few people say work, they typically say energy, but work is what is the most common sense thing to talk about in everyday situations for energy. Then that means then we have to connect work and energy. The way we connect work and energy is something called the work energy theorem. And this literally, this defines the concept of energy. Even though we can write down the different types of energies, you're going to see that we're going to limit our situations to really 3. Sometimes we might have a different one, but the vast majority of the time, we're going to talk about potential energy, kinetic energy, and frictional energy. And then here's the important thing. The most central idea in all of science, and I mean all of science without any doubt, is conservation of energy. Conservation of energy is used by every science ever. And so conservation of energy is a way of how to encompass very conceptually what's going on. But we're going to focus primarily on something called not conservation of energy, which is a broader term, but conservation of mechanical energy. And you're going to see that we start with work, we transition from work into energy, and then we completely transition into energy. And conservation of energy is a very abstract concept, very abstract. So let's get started. So the first thing I want to talk about is I want to talk about work. Okay. So it turns out that my family had a small business selling fruit bars, Mexican fruit bars. So I would say that my family had a small business that sold frozen fruit bars. Now, this was in Tucson, Arizona. And when you look at Tucson, Arizona, they typically have 100 days in a row of at least 100 degrees Fahrenheit or higher. Tucson had a miserable 3 weeks this past summer. They had 3 weeks of temperatures over 110 degrees. It was ugly. I can't even comprehend what that means. So it was a very small business that only ran really effectively for just about 6 months out of the year. So what you find here is that when there was deliveries, we had to bring them in. And so what you find here is that there was boxes, and we typically had to put the boxes onto shelves here or tables. And so when I think about these boxes, I kind of imagine what work is. So one scenario here that you could imagine here is that here I am, not really liking that I had to work, but I was carrying a box of fruit, and my whole job here was to carry this box over to the table over here. So that means my whole goal was to bring this box right there. So I had to put the box over here. And so on the days that there was deliveries, there was a lot of stuff that you had to do. So here we go. What do I think about work? Well, I have to apply a force. I have to pick up the box. And then what happens here is that I have to move the box a certain distance. So a simple definition of work has to involve force and distance. So here we go. So a simple definition of work is how much force is applied over some distance. So then I could come over here and say, okay, here's work. Work is going to be force times distance. So then as a shorthand, we're going to write force times distance right here. And this is a nice working definition. It's a little bit more complicated than that, but we don't need to get there. So now I want to go look at these properties of work, which you are an expert at already. So now we want to go look at properties of work. And there's some pretty surprising things about work that you may know or you may not know. Okay, so the first one is that we could say here is that work depends on distance and force. And so when I look at these, what this does here is that these tell us how much work is done. So we want to do is that we want to take scenarios and do that. So the first thing that I need to do is I need to set up a reference. Okay, here's my reference. So what do I mean by work? So the first thing that I'm going to do is that I'm going to imagine that I'm going to move a block. I have a block right here. And I'm going to move this block this far right here. So when I look at this block, I'm moving it from one location to the next. Right? So what do I see here? Well, I'm going to apply a force that's this big. So I'm going to try to apply a force on this thing, and then it's going to move some distance from here to there. And so that's going to be my distance. So when I talk about my reference situation, I'm going to say that my work in this situation is going to be what? It's going to be this force times this distance. And then this guy is going to tell me that this is how much work I did. That's how big the work is. Now, what's the difference here? The difference here is that if I want to know if I'm going to do more work or less work, so let's focus on distance. So if I'm going to focus on distance, that means that the force has to be the same. So here I go. So I'm going to have this block, but now I'm going to move it farther. So now I have a bigger distance. So when I look at this block, we have this scenario right here. So then the question that we're really asking here is, what does that mean as far as work is concerned? So remember, I focus only on the distance. So that must mean I'm going to keep the force exactly the same. So then what you're seeing here is that if I look at this, that distance is clearly bigger. So you could imagine that if I take a box of fruit and I had to move it much farther away, then what we would expect here is that if I did the same force, but now I moved it a farther distance, what you gotta say here is that that work has to be what? Of course it has to be bigger. You did more work. So if I compare a bigger distance to the reference situation, that's more work. Now let's do it with the force. So what I'm going to do with the force here is that I'm going to do a similar thing. But this time, instead of moving one block, I'm going to move 2 blocks. And then I'm only going to move them a shorter distance this time. So when I look at this situation, you could see that I have twice as much stuff that I got to move. So the only way that I could move twice as much is that I have to do what? Well, first, I'm going to move it this same distance as the reference. So the big thing here now is that now I'm applying a much bigger force. Why? Because I have twice as much stuff to do. So in this case, what I'm really seeing here is that the force in this case has to be larger relative to my reference situation, and my D is the same as the reference situation. And so what you're seeing here is that the work that I get is also really big. So what you're seeing here is that I have these two situations. And we could say here is that there are 2 ways to do the same amount of work. Okay, 2 ways to do the same amount of work.